Welcome to the exercises associated with lecture 1.4 entitled Measurements. I'm going to do the odd numbered exercises first and then go back to do the even numbered ones later. That's because the answer key is for the odd numbered exercises. The even numbered ones I have to do my best. And if the viewer sees something that needs correction or is concerned about something, by all means, post a comment in the comment section of this video. So exercise 35. Is a meter about an inch, a foot, a yard, or a mile? It said in the lecture that it is about a yard, but let me show you how one might be able to do this using Google. So I'll just put Google here, and the question is meter. And just try to throw in, let's say, let's convert yards to meters. And you could see a yard is 0.9144 meters. So that's about the same as a yard. Or we could even do the reverse. 1 meter is 1.09361 yards, which is what was in the OpenStax section. So that's just an easy way to do it. One could, of course, try the inch or foot or a mile. You'll see that yard is the closest unit to a meter. And the answer key says a yard. So we got that right. Indicate the SI base units or derived units that are appropriate for the following measurements. The mass of the moon. We can look at the, I would say kilograms, but just to be sure, let's go to the actual text. And it says the property of mass is measured in kilograms. And the answer key says kilograms. Kilograms is the right answer for the amount of mass in the moon. Okay, the distance from Dallas to Oklahoma City, that's usually stated in kilometers or miles, but they are wanting the SI base units, not the customary units. So the base unit would actually be meters, even though that's kind of odd to state it in meters. If we're talking base units, the length would be in meters. And the answer key says meters. The speed of sound, okay? So this is a little bit subtle, but usually it's the amount of distance per unit time. So we want to state it in terms of the SI base unit for distance, which is meters, and the SI base unit for time, which is seconds. So it would be meters per second. So we have meters per second. Meters per second. And if you're not sure, again, just go to Google and speed of sound. And it states it in terms of meters per second. Now it could be in kilometers per hour or something. Just remember you can convert these units even some more. And so the SI base units would be meters. It's derived. So let's see again what it's asking. The base units or derived units. So a derived unit is we take the SI base units and combine them in some way, like either multiplying them or dividing by them, and we get a derived unit. And I said it should be meters per second, and the answer key says meters per second. the density of air. Now recall, density is the mass divided by the volume. So this should be, and let's take a look, the measurements. The mass is in kilograms, the volume, well, look, it doesn't say anything about volume, but we knew from this lecture that volume can be expressed in terms of, you cube the SI base unit, so it could be cubic meters. This is what will be a little bit, I found that when I've tutored in chemistry, this is sometimes the hardest part, getting all the dimensions right. Same for physics. So it should be kilograms per cubic meter. Kilograms per cubic meter. And I'm happy to tutor someone in this part because it is a little bit harder. So there is a little bit of assumed knowledge, like say, hopefully some high school science teaching to understand this. So I said the answer to the question, the density of air, is expressed in kilograms per cubic meter, and the answer key agrees with that. The temperature at which alcohol boils. Temperature is expressed in the SI base units are kelvins. So let's look at that. Yep, temperature is in kelvins. And the answer key says, yes, indeed, in kelvins. The area of the state of Delaware, it would probably, if you look this up on Google, it would express it probably in kilometers, square kilometers, I'm sorry, kilometers squared or square kilometers. But we're looking at the base unit or the derived unit from the base unit. And in that case, it would be meters squared. And let's see if that, or square meters. And that agrees with the answer key. It says square meters, although again, I'll emphasize that's kind of an odd way to do it. If you look at, like I Googled area of Delaware, it will express it in square miles or something. Let's see. Yep, it expresses it in square miles. And in some places, it'll express it in square kilometers. But since we're talking base units, the correct answer would be in square meters. If I were testing someone, me personally wouldn't be too persnickety. If they expressed it in kilometers or meters, that's fine. I mean, square kilometers or square meters, that'd be fine with me. Likewise, we'll really see this, the volume of a flu shot or a measles vaccine. We would normally express that in cubic centimeters or milliliters, but the SI base unit, derived unit would be in terms of meters. So we would say cubic meters, and the answer key says cubic meters. But again, if I were administering a test and someone said milliliters, I would be totally fine with that, or cubic centimeters, I'd be totally fine with that. Because those are actually the standard units that the physicians and pharmaceutical companies use. They don't use cubic meters. But so I have a little problem with that exercise. There probably is a better way to run that exercise without confusing the students. So apologies in advance, and that's something for me to think about. So let's move on to question 39. Give the name of the prefix and quantity indicated by the following symbols that are used with SI base units. So we have C, and that would be, this is a pretty easy exercise. This is mostly made to force people to review. C is centi, and that's 10 to the minus 2. And that is the answer in the answer key. D, I think that's deci, so let's check that. D is deci and 10 to the minus 1. That agrees with the answer key. Capital G, that looks like giga. And let's just verify that. Capital G is giga, 10 to the 9th. And that agrees with the answer key. The next is K. I think that's kilo. And just look that. K, and it's 10 to the 3rd. That's kilo. And that agrees with the answer key. M is for milli. And let's just verify that. M is for milli, 10 to the minus 3rd. And that agrees with the answer key. N is for nano. I just know that off the top of my head. We'll just verify that. N is 10 to the minus 9th, and that agrees with the answer key. P is for pico, and let's just verify that I'm right. P is for pico, and that's 10 to the minus 12th. And that agrees with the answer key. And finally, capital T, that's tera. T is tera and 10 to the 12th. And that agrees with the answer key. That wasn't so bad. So now let's look at the next exercise. All right, these exercises say visit this PhET density simulation as like what happened with the lecture. When I tried to visit this site, Adobe gave a warning and said it's not going to support this. And so we're just going to skip these exercises. They just can't be done because the simulation is now basically defunct. So apologies to the students for that, but that's not my fault that the simulation's no longer operational. So now let's try to go ahead and do the even numbered questions, and I'll just do it to the best of my ability. Is a liter about an ounce, a pint, a quart, or a gallon? And again, we can just thank God for Google because we could do this very efficiently. Quarts per liter. And a quart is 0.95 liters, or we could say liters per quart. And you could see right there, a liter is 0.9. Let's try this, quarts per liter. There, a liter is 1.05669 quarts. So is a liter an ounce, a pint, or a quart? If you went through all four options, you'd see that it's closest to a quart. It's closest to a quart. 36, indicate the SI base units or derived units that are appropriate for the following measurements. The length of a marathon race. Again, we'd normally state it in kilometers, but we can also state it in meters, which is the base unit. The mass of an automobile would be expressed in kilograms. The volume of a swimming pool, cubic meters. Cubic meters would be the SI derived unit, but if you expressed it in liters, that's also fine. I don't necessarily like the way they're framing this exercise. The speed of an airplane, meters per second would be adequate, but kilometers per hour would also work. But this answer was being very the authors of this exercise are being very persnickety and trying to insist on the SI, trying to express it as close to the SI base units as possible. The density of gold would be expressed in kilograms per cubic meter, but there are probably other ways of expressing it. The area of a football field would be square meters. The maximum temperature at the South Pole on April 1st, 1913, express it in Kelvin, but historical records would probably indicate it in Celsius. Okay, give the name and symbol of the prefixes used with SI base units to indicate multiplication by the following exact quantities. 10 to the third would be kilo, and we could just verify that to be sure. 10 to the third is kilo. 10 to the minus 2 is centi. Let's just verify that. 10 to the minus 2 is centi, or C. 0.1. Let's look at 0.1. I need to absolutely make sure of this. 0.1 is deci. 10 to the minus 1. Or D, the symbol is D. And so what did they want? Give the name and symbol. So the name is deci and the symbol is D. 10 to the minus 3, that's milli, and it's in M. I'm going to point out something that's a little bit funny. Milli is M. Milli is M. It's 10 to the minus 3. Now let's look at something for the symbol for meter. Symbol for meter is M also. So this is really kind of a little bit problematic, because the symbol of the unit for length is an M, and it's also the symbol for the multiplier, the prefix. I just need to point that out, so be careful. It can be confusing. So the prefix is associated with SI units to indicate multiplication. Okay, 1 million, that would be mega. And let's just make sure I got that right. Mega, 10 to the 6 in a capital M. 10 to the 6 is 1 million. And 0.000001, that's 1 millionth. 1 millionth. So that's 10 to the minus 6. Again, one might need to review scientific notation, but to see how many to count how many degrees, we just moved the decimal point. Kind of hard to describe this on the fly. So we have to move the decimal point -1, -2, -3, -4, -5, -6. So it's minus 10, it is -6 degrees, minus 10 to the minus 6 is the exponent, 10 to the minus 6. And sometimes one will just start to know this intuitively, and you don't actually have to do the math in your head. So that would be 10 to the minus 6. The prefix is micro, and the symbol is the Greek letter mu. And so that's it for 38. For 40, okay. A large piece of jewelry has a mass of 132.6 grams. Notice it's grams, not kilograms. A graduated cylinder initially contains 48.6 milliliters of water. When the jewelry is submerged in a graduated cylinder, the total volume is 61.2 milliliters. Determine the density of this piece of jewelry. Okay, so let me see if I can. can either do this in Microsoft Word or let me see here. So what did it want? Let me get the font nice and big so it can be seen. So the mass equals 132.6 grams. The volume is not clearly stated, but if a graduated cylinder, that's just a measuring device that you can measure how much liquid there is in something. If a graduated cylinder contains 48.6 milliliters of water, and then you put this jewelry inside that same cylinder, the water will rise. It's just imagine a small glass, and if you throw something into the glass, you'll see the water level rise. The graduated cylinder is just a very precise way of measuring volume very exactly. So we could say that if the final volume is 61.2 milliliters, and we subtract 48.6 milliliters, we get the volume of the joule. So let me put that in my calculator here. So what were the numbers again? I love using spreadsheets. So 61.2, 48.6, and using a spreadsheet, I can go to one cell and just say, highlight a number, highlight a cell, and subtract another cell from that. 12.6. So that would be 12.6 milliliters. So now the question is, determine the density of this piece of jewelry. And density we sometimes use the symbol rho, but I'll just use the word density equals mass divided by volume. And that equals 132.6 grams divided by 12.6 milliliters. And I'll just put this in my calculator here. So that's milliliters. And what was the number of grams? It was 132.6 grams. 132.6 grams. So we divide 132.6 grams by 12.6 milliliters. I could do that on my spreadsheet very efficiently. So I say 132 divided by 12.6 milliliters equals 10.52. I'll just round off to 10.5, and that would be grams per milliliter. So that's my answer. 10.5 grams per milliliter. Assuming that jewelry is made from only what substance is it likely to be? We can go through the periodic table. And since this is jewelry, I would say the only single substances would be, like say, we could try gold or diamonds. So density of gold. Okay, a cubic centimeter cc to cubic centimeters. Okay, 1 cubic centimeter. Okay. Okay, so okay, 1 cubic centimeter is equal to 1 milliliter. Okay, apologies to the viewers here. I had to just try to do this quickly. So if it says per cc, that's also per milliliter. Per milliliter. Density of diamond. 3.5. How about silver? 10.49 grams per cubic centimeter. Now remember, a cubic centimeter is equal to a cc, which is equal to a milliliter. Okay, this is not an easy question. You'd have to do a little bit of digging, which okay, this is not a quick answer, and I had a lot of prior knowledge, and that's why I was able to do this quickly. So this would be like a bonus question. So we have here the density is 10.52. Now, I would say that's not exactly, I would suspect this had some impurities that made it a little bit more dense. But given these numbers that our figure, what did we compute here? That it's roughly 10.5 grams per milliliter. And the density of silver is 10.49 grams per milliliter. Now, just to make this clearer, that's also equal to 10.5 grams per cubic centimeter. And so hopefully you could see I just Googled density of silver. I got 10.49 grams per cubic centimeter. Our calculation was roughly 10.5 grams per cubic centimeter. That's close enough for me. I would say that the jewelry is made from silver. And then that's it. The other exercises, as I said, we can't do. So thank you for joining us today, and God bless you.